Welcome, and this video is a continuation of my series where I am making a geometry set using Techsoft Design to be laser cut. I've already looked at the ruler and now I'm going to be having a look at the set square. So the set square that we're going to be creating is this set square here. So it's going to be an isosceles triangle with two sides being 90 millimeters in length, separated by a right angle at 90 degrees. And then on the hypotenuse here, we're going to have some centimeter and millimeter markings ranging from -5 to +5 with 0 in the middle, and the 0 is going to be aligned there with the right angle corner. I'm not actually going to draw it in this orientation. I'm going to draw it rotated clockwise by 45 degrees. You'll see what's going to happen now in Techsoft Design. So I've got a new CAD file here. You could start a new one, or you could continue to work on the CAD file that you were using to make the ruler. And I'm not going to use a line tool to draw this shape, because if I do a series of lines, then they're actually classified as separate lines. And that means that I can move them all apart, separate them, and that could be useful. But in our case, I don't think it is. Instead, what I'm going to do is come to Tool B3, which is here in the top left of the screen. I'm going to hold the mouse button down, and I'm going to go to the fourth tool along, which is called the Open Polyline. What this will allow me to do now is simply, draw a series of lines by left clicking, and then I right click to finish. Okay, let's undo that. I don't want that. There's also something very interesting happening here in terms of, as I'm drawing lines here, you can see that it's kind of snapping to various points on the grid, but not necessarily following the grid itself. And that's because I've turned on a radial lock. Now, if I turn a radial lock off for a second and do some more lines, you'll see that now I can literally position, exactly on the grid where I want those lines to be. But because I'm going to be making this isosceles triangle, it might be useful to work with a radial lock. Now, I'm going to right click on the radial lock tool up in the top right corner here, tool D3, and I'm going to set the step angle here to be 45 degrees. And I'm going to turn on only active on line drawing and marquee box rotation, which is super important because then it's not going to be getting in the way when I'm doing other general things. So definitely turn that box on. Now that means that as I draw a line, it's going to be snapping to the vertical or 45 degrees or to the horizontal. And that's going to make the drawing of my isosceles triangle that bit much easier. Okay, I'm going to get the selection tool. I'm going to put a bounding box over all these lines, and I'm going to press the delete key on the keyboard. Okay, there you go. Let's start to draw my set square now. So remember, it wants to be 90 by 90. Okay, so with my polyline tool, I'm going to click near the top, and now I'm going to come down 90 millimeters. Now, as I did with my ruler, I'm going to be looking down here at the relative grid reference point, okay, and I'm looking at the y value, which is going to be to the right hand side of this rectangle here. Okay, that's why I want to see -90, and now I can see it says -90 in the relative grid reference in the y-axis. I'm going to click, and then now I'm going to come to the right, and my x-axis wants to say 90 millimeters, sorry. And then now I'm going to come back up to the left. And because I've got radial lock turned on, look, it's going to naturally give me a 45-degree angle there, and then click at the start of that isosceles triangle. Now I'm still drawing, so don't forget I've got to right click to finish that process. Let's make sure this is all working correctly. I'm going to come down now to the dimension line tool in the top left, which is tool B5. And I'm going to click at the top, click at the bottom here, and then click out to the side. I can see that's 90. Okay, let's click again for the bottom dimension. And then I'm also going to look here at the hypotenuse. Now, I don't really want to measure this hypotenuse, but it's going to be just fun to see what's happening. And I get this strange value here, 127.28. Where is this coming from? Well, you may know that there are rules for calculating the length of a hypotenuse with isosceles triangles, and this is the formula right here, or this is the symbol we're looking for. The square root of 2 multiplied by the length of one of the sides. So let's just bring up calculator here, and let's just see what we can do with that. So I know that I've got 2, I want the square root of 2, 1.414, and I'm going to multiply that by 90. And that gives me 127.28, because I round up here 0.28 millimeters, and that's the dimension we have here. So that's the hypotenuse. Now, I'm not going to worry about that distance because I'm working with integers, and that's an odd decimal place, and it's been defined anyway by the fact that we've got 90 by 90 in the isosceles triangle with a right angle. So I'm going to delete that. However, what I can do here, I can come back to the dimension line tool, I can come along here to the angular dimension tool, and now I can start to just identify that that's going to be 90, this is going to be 45, and that is going to be 45 there as well. Now, that's getting a bit cluttered now. So actually what I'm going to do at this point is I'm going to select that triangle. Remember, I've still got gridlock turned on here. I'm going to copy that, I'm going to paste it, and I'm going to now work on this version of my set square of my set square. Yes. Okay. So that could be my model with all my dimensioning laid out. And here's the version I'm actually going to start to work on. Now, one of the things that I need to do is make sure that I've got my centimeter and millimeter markings on here. And the way I'm going to do that is I'm going to be rotating this design through 45 degrees. And my center of rotation is going to be the endpoint where the 0 mark is on the ruler. So if I click on my design here, I can see that there's this little square, which is actually the midpoint of the hypotenuse. And because I've got a radial lock turned on at 45 degrees, I can now click on this rotate tool, rotate it through 45 degrees, click again, and now I've got my set square in this new orientation, which is going to allow me to take my millimeter and centimeter markings from my ruler, copy them, and paste them in to this design. All I need to do then is change it. So rather than being from 0 to 18, it's going from -5 to +5, with 0 being the point which is the center of the hypotenuse and which aligns with the right angle of the isosceles triangle. And that will then be ready for me to add my graphics and my client's custom font and then send to the laser cutter. This video is going to stop now. I'm not going to go any further with these instructions. You know how to make the ruler. You could copy it. So you know how to make the millimeter and centimeter markings and the numbers. You could take it from your ruler and modify it. You know how to work with graphics. You know as well how to add the color codes for our laser cutter to be able to interpret your CAD file so it knows what to cut and what to engrave. The last thing I'll say here is don't forget when your set square is finished, don't forget to select it all and then group it all together so that the things aren't separated and it's easy to manipulate when we send it to be laser cut. Okay, good luck with that.